Hello, Fifth and Sixth Grade. This is your science video for Friday. Sorry I didn't get to it until Saturday. I had intended to post it on Friday, but then I had to go to Yakima to pick up a car. Mrs. Jones and I were able to purchase a new vehicle, and that was where it was, and I had to go, and so that's why it wasn't posted yesterday. All right, so we're going to be on page 118 to 123. I'm going to help you out a little bit with answers later. So your secret word I'll give you to you right now. The secret word is going to be, we'll just say Tucson. That's the new car we got, so I'll just say Tucson for your secret word. So the first part is about moving air, and it's about weather and how weather occurs. And this is called this section is called moving air. It says you're surrounded by air that is usually moving. Moving air is called wind. Sometimes wind moves so slowly that the air seems perfectly still. Other times it blows violently and destroys everything in its path. We can use and enjoy wind in many ways. A light breeze may cool us off after a ball game. A stronger wind may allow us to fly a kite in the air. In times past, great winds pushed the ships of explorers across the oceans. Today, some people exercise dominion by using wind to help produce electricity. Air temperature. Although the heat from the sun comes from the atmosphere, or comes through the atmosphere, the sun does not warm the air much. Instead, the sun warms the Earth's surface, which then warms the air above it. Air temperature is a result of the heating and cooling of the Earth's surface. The curved surface of the Earth affects temperatures. Sunlight hits some places from overhead and other places at a slant. The places that receive overhead sunlight are warmer than those that receive sunlight at a slant. Also, the part of the Earth facing the sun receives heat and is warmer than the part facing away from the sun. Now, what they mean by that is, and it does mean each day as the Earth turns, then that part's going to receive more sun. But if you look at the picture that's above, the Earth is on tilted on an axis of how it spins. The axis is how the Earth spins. And so if you look at the top of that page, you notice that this is the sun is more directly in the northern hemisphere. Which means it's summertime in the northern hemisphere in this picture. It is pointed directly over, it looks like what would be about the 23-degree angle or north on the globe. And so if you know anything about your longitudes and latitudes, that is as far north as it goes. The Tropic of Capricorn, I think, or maybe Tropic of Cancer is as high as the sun will be directly over. And so where the equator is, that is the warmest of the areas of the world. Not always warm. Sometimes mountains and things like that influence that as well. But the curved surface of the Earth, that's what causes more sunlight. Then there is something else that's going to be coming up that you'll find out that actually affects the temperature and where it goes and that type of thing. So it says on the bottom there, on the bottom right of 118, it says, since the Earth's surface does not heat evenly, the air in the atmosphere does not heat evenly either. This is why days are usually warmer than nights. Air masses. A large body of air that has about the same temperature and moisture is called an air mass. An air mass gains its characteristics as it moves over the Earth's surface. For example, an air mass over cool land or water becomes cooler. An air mass over an ocean will also collect moisture. As an air mass moves over a hot desert, it becomes warmer and drier. Air masses also vary in density and air pressure. The gas particles in cool air are close together, causing cool air masses to be denser than warm ones. This is why cool air often has greater pressure. The zone of highest pressure in a cool air mass is called a high pressure center, represented by a capital H on a weather map. Because cool air cannot hold as much moisture as warm air, the cool air masses usually have cool, dry air. A cool air mass is cooler than the land under it. Over several days, the warm surface of the Earth heats the air mass. Warming allows the air to hold more moisture and causes the gas particles to spread out. As the air becomes less dense, the air pressure of the warm air mass becomes lower. The area of lowest pressure in a warm air mass is a low pressure center. It is shown by a capital L on a weather map. Now, you can see there, science history, the hot air balloons use changes in air density to move up and down. Heating the air in a balloon moves the air particles farther apart. As the air inside the balloon becomes less dense than the air outside, the balloon rises. As the air inside the balloon cools, the balloon drops. Hot air balloons have been used in the military since the Civil War. That would have been an interesting thing to see then. The balloons were used to observe the location and size of enemy armies. Today, some balloons are still used for surveillance along our country's borders. All right, and so fronts on the next page there. We are talking about fronts here. There are three types of fronts that you'll be dealing with. Now, there are a lot more types of fronts because there are all kinds of mixes of them, but these are the three main ones that you will be needing to remember for this. And then the pictures in there in particular are important because you'll see those on quizzes and tests. So the fronts, when two unlike air masses meet, the boundary between the masses is called a front. A cool air mass may push itself under a weak warm air mass. This type of front is called a cold front. So you see the top picture there. It's like a wedge. It's driving underneath the warm air. It causes the air to rise, and as the air rises, the air that's in the warm air mass cools, and then it causes clouds to build up because the higher it goes, the colder the air gets, and that means the less moisture that air can hold, and so it starts to form, starts to condense, and it causes clouds to form, and then eventually rain. Once it starts to have enough warm air that builds up to that level, or if the air already has a lot of moisture, that would be another reason why. It often brings stormy weather that may include thunderstorms and hail. A cold front usually moves quickly through an area. After the cold front passes, the weather is usually cooler and drier than before. A warm front occurs when a warm air mass moves over a slower, cool air mass. A warm front moves slowly and can take several days to leave an area. As a result, a warm front, a warm front often brings several days of light rain or foggy weather. When a warm front passes, the following days may have warm, moist weather. Sometimes air masses push against each other but do not move. When this happens, the boundary is called a stationary front. And so you can see they're sort of pushing against each other, and they just stay there. They really are stationary. And so on one side, you can go 50 miles one way, and it'll be a lot warmer. And you go 50 miles the other way, and it can be a lot cooler. And so you can actually have two different types of weather there. But a stationary front may stay in the same place for several days and usually causes cloudy skies and rainy conditions. Okay, next part is kinds of winds. Air varies in temperature. Many factors such as location or cloud cover affect the air temperature and can make it warmer or cooler. For instance, air near the surface of the earth is warmer than air at higher altitudes. Air is also warmer near the equator and cooler at the poles of the earth. Changes in temperature cause wind. Where warmer air rises, cooler air moves toward the earth to replace the warmer rising air. These and other air patterns influence the movement of winds. There's something, I don't think they mention it here, but there's something that also affects winds that they don't talk about, and that's called the Coriolis effect. And that's as the earth spins and that air is rising, then as it's spinning, that means it's moving sideways. Because the air is going up, but the earth is spinning, and so as it's going up, then the air starts to move in a different direction. Global winds. The uneven heating of the earth causes global winds. Global winds occur in large circular belts around the earth. Global winds include trade winds, the prevailing westerlies, and the polar easterlies. Winds are identified by the direction from which they blow. The prevailing easterlies or trade winds blow from the east toward the equator. Christopher Columbus used the prevailing easterlies when he sailed to the New World. These winds became known as the trade winds because trade ships relied on these strong winds to sail to the Americas. After trading their cargo, the ships would then return to Europe using the prevailing westerlies. In the northern hemisphere, these winds blow northward from the west. Near the North Pole and the South Pole, the polar easterlies blow from the east and move away from each pole. And so those things you will need to know a little bit detail, but you'll get some of that in your worksheet anyway. Local winds. Other winds, known as local winds, are influenced by temperature changes in a small area or place. During the day, both land and water absorb heat from the sunlight. At night, the land and water cool as heat moves toward the atmosphere. Land and water absorb heat and cool off at different rates or speeds. Warm water, by the way, water is the one that cools or warms more slowly. So it'll stay at its same temperature more readily than the land will. Water warms and cools more slowly. Same thing I just said. More slowly than soil and rocks do. Places where water and land meet often have local winds called sea breezes and land breezes. Winds form as cooler air moves to replace warmer rising air. During the day, the air over land is warmer than the air over the larger bodies of water. This causes the sea breezes to blow inland from the cooler water. At night, the water and air above it cool down slowly and stay warm longer than the land does. This causes land breezes to blow from the cooler land toward the water. Valley winds and mountain winds are other types of local winds and form in a similar way. During the day, the sun warms the side of a mountain and the air around it. As the air warms, it becomes less dense. Cooler, denser air from the valley moves up the mountain to replace the warmer rising air. These winds are called valley winds. At night, air at higher altitudes cools quickly. Mountain winds occur as cooler, denser air flows down the mountain to replace the warmer, less dense valley air. All right, and then it says a wind vane. Now, we have one on the building here. It's one that I put up a few years ago, but it says a wind vane, and you see the picture of it right up there at top. A wind vane is an instrument that shows the direction the wind is blowing from. It shows the direction of the wind by pointing into the wind. The speed of the wind is measured using an anemometer. An anemometer looks like several cups attached to a post. As the wind blows into the cups, they spin around the post. A dial that looks similar to the speedometer in a car shows how fast the wind is blowing. If the winds become too strong, an anemometer may be damaged. The one at Isaac Klein's weather station was blown off the building by strong winds. And I think the strongest, fastest wind was on the top of a mountain. It was 200 and something miles an hour. It was recorded before the wind vane broke. And so you can have one that does a lot and lasts a long time. But all right, so look at your worksheet. You're going to have 3 pages, 84, 85, and 86. Now, on 84, it's going to be the bottom part. You can look that right in your book, and you can do it. And also for the masses, the air masses, and it tells you what happens to it, or you've got to identify what happens to it. But in the study guide, since these are things that you've already done, I'm going to go ahead and just give you the answers for these, make it easier for you, and you can stop me as you need to. But on page number 85, which is that first page, it's the study guide. So you've got these are your answers for page 85. It's DBACE, so DBACE. Number 6 is high pressure air mass usually has cool, dry air. Number 7, low pressure air mass usually has warm, moist air. The instrument that shows the direction wind is blowing from is a wind vane. The wind speed is measured by an anemometer, and winds are identified by the direction from which they blow and changes in temperature. And so I'll let you answer those 3 on the bottom. Those are pretty easy as well. And then on the back side, you've got the 3 on the top, which are trade winds for number 14, prevailing winds for number 15, and polar easterlies for number 16. And so they basically were all in the reading that we just did. But there they are for you. And then the 4 pictures on the bottom, I want you to be able to identify those yourself. All right? Well, that's it. I hope you guys have a good weekend. We'll see you on Monday. Look forward to our shortened week for Thanksgiving. Have a good day. Bye.